Good afternoon. Let's continue. Allow me to take a call, just one call. We are starting shortly. Confirm if you're present. Confirm, confirm. Ale, Ale, Ale. Okay, all right. So let's continue. So we were looking at IS, ISIS authentication type, and we have seen that we have these three authentication modes. That is interface, area. We also have routing domain authentication and where they are applied. We also discussed the type of LSA, sorry, packets that are authenticated. So we have the LO packets for interface authentication. We have the complete sequence number PDUs and partial sequence number PDUs, and also link state PDUs, which are used under area authentication. Okay, yeah. Routing domain authentication also applies to level twos. So these ones are used, routing domain are used for level two. Notice that level two CNSP, PSNPs, and LSPs. Area authentication is for level one. Okay. Yeah. Kindly note these areas. Okay. I'm not going to delve to this. So when you're configuring authentication, you can do it on the interface. You select the interface, then you type in the authentication mode. Then for area, you go to the ISIS process. Then you key in the mode, the authentication mode that is involved. For the domain, you also ISIS. So this one you say it's a domain authentication mode. Now let's look at ISIS for IPv6. ISIS with IPv6. So ISIS is a link state dynamic routing protocol which was initially designed for OSI networks, but later it was upgraded to provide extensions for IPv4, also now IPv6. Okay. So ISIS packets are classified into LO protocol data units, PDUs, and the link state PDUs, that is the LSPs, link set values. Okay, yeah. So we have the hello protocol data units, and we have the link state PDUs, and we also have the sequence number PDUs, the ones that we are calling SNFPs. So we have for SNPs, we have two types. We have the complete sequence number PDUs, and we have the partial number or partial sequence number PDUs. So we have the complete sequence number PDUs and the sequence partial sequence number PDUs, right? Hope that is clear. So we say we have what we call the type length value. This one should be type, not variable length. Type. It should be type length value, type length value. Give me a minute. Give me a minute. Let me check my internet connection. Just a minute. All right. So, so we have the type length field. The type length. This type length. We said this is a feature in ISIS, which is used now to provide for flexibility and scalability in terms of packet construction. So when forming the packets in ISIS, TLV values are used to add more features. Okay. So to support more features, TLVs needs to be added. Okay. So to support the processing and calculation of IP routes, ISIS adds to TLVs, that is type length value fields. And also it adds one network layer protocol identifier, NLPID. Okay. Yeah, the network layer protocol identifier. So the two TLVs that are added in ISIS include TLV number 232 and TLV number 236. Okay. TLV number 232 is equivalent to TLV number 132, which is found on IPv4 networks. And this one is used to provide, or rather, it describes the IP addresses that are in the someone saying can't hear us. So do you get from? Can you hear me? Can the rest? Yeah, yeah. Marie can hear, Linus can hear, and Linus hear. Am I audible? Okay. All right. Tell them, type for them there on the public chat and tell them to rejoin the meeting. So 232 is similar to 132. It describes the IP addresses. So here, the only difference between the 132 and 232 is that 232 is majorly using IPv6 addresses. So it describes a 128-bit value, which is what is used for IPv6. Okay. Yeah, IPv4s are 32 bits. We say that an IPv6 address is 128. IPv4 is 32 bits. Okay. Yeah. So this one describes the IP address in an IS packet. Then we have TLV 236. So this is for IPv6 reachability. This one is similar to TLV number 128 and TLV number 130, which is found in IPv4 networks. So this one is used to define the to divide. It defines how we can be able to reach certain parts of the network. Okay. So this one uses other is used now to provide IPv6 reachability. Okay. Yeah. Provide how we can reach certain destinations in the IPv6 network. Now, something else about ISIS is that ISIS supports the multi-topology design. We refer to this as dual stack. Dual stack is a concept that we use to refer to a network that combines both IPv4 and IPv6 topologies in the same instance. Amit plays uh, the same path tree for both IPv4 and IPv6. Okay. Yeah. So ISIS single topology has this following problem. Okay. So if you have one topology, you'll have this kind of challenge. That routers that support IPv4 and IPv6 dual stack cannot detect routers or links that do not support IPv6 and may still forward IPv6 packets to them. So as a result, as they are sending these IPv6 packets to those interfaces or routers which do not support IPv6, then that will lead to uh, guarding of the packets and hence forwarding failure. Okay. Another issue is that routers and links that do not support IPv4. Okay, we also have some routers and devices that do not support IPv4. So in such a case, these devices won't be able to get or to access. Someone is saying I am on mute. I think rejoin here. Tell them to rejoin here. Thank you. So devices that do not support IPv4 in the topology, when they receive the IPv4 packets, they will discard them and will have a forwarding failure. So ISIS supports what we call dual stack topology. Dual stack is where you run both IPv6 and IPv4 topologies together. Topology. So this ensures that ISIS routes are calculated for both IPv4 and IPv6 networks. So this is based on the IP version supported on bylinks. So we can have separate SPF calculations, that is shortest path first calculations, performed in each topology. And then we also have that abstraction where each topology is going to operate independently and it won't affect the other topology. So in ISIS multi-topology implementation, we usually have neighbor relationships established through packet exchange in order to set up the multiple topologies. And then shortest path first calculations are also performed on each side of the topology. So we call this dual stack. In case you find it in the exam, dual stack means that you're running both IPv4 and IPv6 topologies together as an integrated topology. Let's answer these few questions. So the first question is a multiple choice question. It's asking, which of the following statements about OSPF and ISIS are true? A, both OSPF and ISIS are link state routing protocols. B, OSPF supports only IP networks, whereas ISIS supports connectionless and IP networks. C, OSPF uses area 0 to identify the backbone. And D, ISIS backbone areas consists of level 2 and level 1, 2 routers. We asked which of the following statements are true. A, is A true? Both OSPF and ISIS are link state routing protocols. The answer is Yes. B, OSPF supports only IP networks, whereas integrated ISIS supports connectionless protocol and IP networks. That is correct. Then we have OSPF uses area 0 to identify the backbone area. That is true. And then we have ISIS backbone area consists of level 2 and level 1, 2, and that is correct. So A, B, C, D are true answers. Let's have question number 2. Which of the following statements about level 1 routers are true? Level 1 routers, okay? So level 1 A, level 1 routers can establish neighbor relationship with only with ISIS routers of the same area. Is that true or false? Yes, it is true. B, a level 1 router can establish a neighbor relationship with a level 2 router in the same area. B, no. Okay. Yeah, level 1 and level 2 cannot establish neighbor relationship. C, by default, a level 1 router can reach the destinations outside. We are talking of can reach destination outside the area only through the default route. Yes. 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 This one somewhere. Okay. Yeah. So level ones can reach level twos through the default route. That's correct. Then we have D. The LSDB of a level 1 router contains only level 1 LSPs. The answer is correct. So it's A, C, and D. So this concludes our review on ISIS. Okay. Yeah. So we're going to delve into the next topic. Allow me to allow me to check something here just briefly. Give me 5 minutes. I will respond to something here and then we can continue. 5 minutes.
Niulize mimi moja sija.
Hello. Tengo una tía.
Check.
Okay, let's continue. Someone asked, for the first question, I thought he was wrong. First question. Okay, backbone route, as we said, we have level 2 and level 1, 2. Backbone for D, this one is correct. So Level one is in these are routers that are found in the non-backbone areas. I hope, Solini, you answered. Yeah. So I want us to look at another protocol, another interesting protocol we call BGP, Border Gateway Protocol. I will be brief. I'll just be giving you an intro of what these protocols do. When we meet again for the regional final preparations, then I will be able to take you through the details. Okay, yeah, I'll be able to take you through the details for regional final preparations. I want to hope all of you are going to tie in one position and qualify. Okay, yeah. So wishing and hoping everyone will have a good fight. Let's battle it out. Remember, there are great opportunities ahead. Very great opportunities. If you are, for those who are going to qualify, you're going to enjoy the whole journey. It will be one journey that will revolutionize everything you've been doing and also change your life for the better. Okay, so let's look at BGP. Okay, BGP basics. You'll notice that we have a lot to cover. Okay, there is a lot to cover. So BGP is also very wide. It's not like we have seen with OSPF and ISIS. So this is also one of the most popular protocols. So let's start. So BGP is an exterior gateway protocol. Exterior gateway protocol. It is used to dynamically exchange routing information between autonomous systems. We use it to exchange routing information between autonomous systems. Okay. Yeah. So BGP does not operate like in our OSPF and ISIs. It operates differently. We're going to see, and also we're going to see the motivation behind it. Why BGP? Okay. Yeah. So eBGP, we're not going to look at history. Just going to go straight to what BGP does. So I'm going to say BGP selects optimal routes and also helps to prevent routing loops. It also transmits routing information efficiently, and not just efficiently, it can be able to handle large routing information, large amounts of routing information with ease. Okay, yeah. And it maintains lots of routes. That's the word I was talking about. It really can serve a large network. One of the large networks that we have out there is the internet. Okay, yeah, the internet. The internet has so many routes. I don't know how to quantify them. They are in maybe trillions of routes per second. Every second we generate more than trillions of routes. Okay, yeah. You can imagine everyone who is accessing the internet right now, they are seated somewhere on a network, and that network is connected. So PGP is there to support large networks. Now we're going to look at some concepts here. The first concept we're going to deal with is an autonomous system, AS, autonomous system. So an autonomous system is a collection of devices. It is a collection of devices that are managed by the same organization. Okay, and this collection of devices use the same routing selection policy. So they're managed by the same organization and they use the same routing or networking policy. So to distinguish autonomous systems, we assign these groups of devices autonomous system numbers. For instance, you have organizations like Safaricom, which is a carrier network providing broadband services. We have companies like Airtel, Liquid Telecom, Seacom. All these companies form, or rather, they have unique autonomous systems. Okay. So, for instance, the network at Safaricom operates differently from the network at Airtel. Okay, and Liquid Telecom and any other company like Seacom. All these networks are unique in their own. They are managed by the same routing policies. Okay, which are proprietary to the organizations they belong to. So to identify these organizations' networks, or rather what we are calling autonomous systems, we use what we call autonomous system number. For instance, for this network that is shown on this diagram, we have autonomous system number 100, we have autonomous system number 200, okay? Yeah. So there is to distinguish the autonomous systems. Okay. So an autonomous system number is that ID that uniquely identifies an organization's network, rather S network. So the number is usually 16 bits in size, or sometimes even expressed in the 32-bit format. So these numbers are uniquely assigned by an international body we call Internet Assigned Numbers Authority, IANA. And they assign S numbers and also IP addresses. We saw that the IANA also assigns public IP addresses to institutions, okay? Yeah, so they also assign autonomous system numbers. Okay, so in case maybe you ask for to give numbers that are assigned by the Internet Assigned Numbers Authority. One is public IPs. Two, we have autonomous system numbers, and we also have other numbers that are responsible for different operations that are also assigned by the same body. So when different autonomous systems need to communicate with each other, the routing protocol that is used now to transmit routes is BGP. That's why we have this question mark. So to connect these two guys, we need BGP. So we use BGP to transmit routes between different autonomous systems. Another thing about BGP is that it provides security in that it doesn't expose the topology of a given organization network, or rather the topology of a given autonomous system. So for example, Airtel and Safaricom are connected because we want to have that kind of interaction. So we have Airtel users, we have Safaricom users, and they all communicate with each other. So when you're using a phone, a Safaricom line, and you want to call an Airtel person, there is a link somewhere where Safaricom has integrated their network with Airtel's network. Okay, so the protocol that is serving that interface is BGP. Okay, yeah, BGP. So let's look at BGP, our close plans at BGP. So we have said it works between autonomous systems and its purpose is for route transmission. Now, compared with other conventional IGPs, BGP has the following characteristics. One, it runs at the transport layer. So BGP runs at the transport layer. These other guys run at network layer for OSPF and network and data link for ISIS. But BGP runs at the transport layer and it uses TCP. It runs on TCP, and it is TCP port number 179. 179 is the port that is used now to exchange routes between two adjacent or two neighboring routers. Okay, yeah. The other thing about BGP is that it can transmit large amounts of traffic or the routes. So BGP can transmit large amounts of traffic. There's a really good leverage that you can handle large sizes of routing information, okay, as compared to IGP, that is OSPF and ISIS. Okay. The other thing is that BGP only transmits routing information but does not expose the topology. That's something we mentioned. So, hence protecting the integrity of that organization's network. The other thing is that BGP routes are updated only after the network changes. So we don't send hello packets. Okay, we don't send hello packets. When the network is stable, we stop exchanging protocol information. Okay. Okay. Yeah. So those are the features of BGP compared with OSPF and ISIS. Now let's have a close overview of BGP. So BGP, we are saying, is a path vector protocol. Path vector. What does a path vector mean? Is that it defines the path through which packets are forwarded or the routes are discovered. So it is used to guide. Let me moment. Okay. Was multitasking. Sorry. Okay. So BGP is a path vector routing protocol, which allows devices to communicate between autonomous systems. Okay. It also selects the optimal routes, which will be used for forwarding traffic. Now, BGP has undergone a number of developments. We have currently two versions. We have BGP itself, which is ideal for IPv4 networks. We just call it BGP. Okay. It's called BGP4. Sorry for that. But it has undergone a number of development. We started with BGP 1. Okay. But now currently we have BGP 4. Okay. And this one is used for IPv4 networking. Okay. And we have also seen the advancement in BGP4, where we currently have BGP4 plus, BGP4 plus. That's not captured here. BGP4 plus. And this one is ideal, or rather is used for IPv6 networks. So BGP4 plus is used for IPv6 networks. BGP4, just use it for IPv4 networks. Just write somewhere, capture somewhere. Okay. Sorry, okay. Yeah, so BGP4 plus is for IPv6, BGP4 is for IPv4. So characteristics of say that BGP uses transport layer and uses port number 179 for communication. Okay. Yeah, so it executes at the transport layer, and it uses the transport layer to trigger route updates. Okay. So we say BGP does not send periodic updates. Okay. So instead of sending periodic updates, we trigger them at the transport layer. Okay. So whenever we have a problem with at the transport layer between two routers, then now we can trigger updates there. So BGP can carry large amounts of routing information, and it's ideal for large-scale networks. Another thing about BGP is that it provides various routing policies to flexibly select routes and also instruct peers, BGP peers, to advertise routes based on certain routing policies. Then another beautiful feature about BGP is that BGP is also used to support VPN communication or other VPN routes. Now, to support BGP, to support VPN routes, or rather to transport VPN routes, BGP works with another protocol we call MPLS. MPLS stands for multi-protocol label switching. It's a labeling protocol which helps now to speed up the forwarding efficiency on routers. We are going to discuss it shortly. So MPLS and BGP and VPN will be used together to form what we call BGP IP BGP MPLS VPN. So this is a tunnel that is used now to transport VPN traffic from one area of the internet to another area of the internet. So this happens on the internet where we have uh, um, unsafe, that is where we have a vulnerable environment like the internet. So to transmit VPN traffic from one zone to another through the internet, then BGP can work with MPLS and VPN technologies to transport these VPN routes. Another thing about BGP is that it supports route summarization. It also performs other operations on the traffic like route dampening, which help to prevent route flapping. Network flapping means that the network is changing frequently than expected. So when the network is flapping, that means that sometimes uh, 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 packets will packets will not be forwarded correctly. Okay, yeah. So to prevent the network from changing, which we call flapping, BGP has mechanism we call route dampening, which ensure that the path is not going to change no matter what happens to the physical state or to the forwarding status of the link. And hence it enhances network stability. Okay. Yeah. So let's continue with characteristics of BGP. So BGP comes in also with additional features. So we have features that we call BGP attributes. So these are like characteristics of BGP in that they offer additional functions to the BGP packets to allow for easy transfer of information from one location to another. So each BGP route, it carries multiple path attributes. So as you're sending a BGP packet from one router to another, the packet is going to carry additional information that can be modified by other routers that are in the path of the packets to the destination. So different from ISIS and OSPF, where we use cost to select path. BGP selects paths based on path attributes. So BGP does not select the path based on the cost, rather based on the path as the attributes. So therefore, BGP is easy to operate and allows you to select the most appropriate path to provide control in different scenarios. Okay. So we have said BGP uses TCP, which is a transport layer protocol, and it is TCP port number 179. So BGP sessions between two routers are established based on TCP connections. And we said for TCP connections, we involve what we call the three-way handshake. TCP three-way handshake, okay? BGP three-way handshake. That is a TCP three-way handshake. So this is where we send packets to each other. Other two routers will send packets to each other with a bid of establishing the TCP connection. Okay, yeah. So port number 179 is used as a receiving port for listening purposes. Okay, so the router that is sending packets will generate a random number which is in the range of uh, uh, which is a number that is greater than or equals to 1024 in order to request for the connection, BGP connection. Then the peer will respond with port number 179. BGP uses the interface that sends BGP messages as the local interface for TCP connection. So I've mentioned that when deploying IBGP in your relationship, IBGP means it's internal BGP within the same autonomous system. You're advised that you use the loopback addresses as the source for the TCP connection. Okay, so the loopback, why do we use the loopback address? Because the loopback address is stable. So the reliability can be ensured by using the IGP and redundancy topologies in the so I said for IBGP, that is for internal BGP, that is BGP between routers that are in the same autonomous system. So for internal BGP, two routers can be connected through other links. In other words, two routers may not need to be directly connected to each other for internal BGP. Okay, yeah. For internal BGP, two routers may not be connected directly to each other. All right. So for loopback addresses, we have said they assure reliability that they are stable, and is ideal because we don't affect the service interfaces or rather the physical interfaces that are used for service traffic forwarding. So I was saying two routers in an IBGP can be connected through other routers. So which is not a must that you have a physical link connecting them. They can be connected through other existing parts of the network. But now, to distribute the BGP routes through the system, we use an IGP. I hope you understand what is an IGP, an Interior Gateway Protocol. So here we can use something like OSPF to distribute the routes that have been learned through this side, to distribute them so that they can get here. So we can run OSPF within this autonomous system. The aim will be to distribute BGP routes in the autonomous system. Okay, yeah. Now let's look at eBGP. So for eBGP peer relationship setup, we establish the TCP connection through the physical interfaces that are connecting the routers together. So in most cases, eBGP, the routers will be connected directly with physical cables. Okay, yeah, the routers will be directly connected with each other with physical cables like that. Okay. Yeah, we use the directly connected interfaces for peering purposes. For IBGP, we use the loopback addresses for peering. To peer, peering means joining two neighbors, or that joining BGP speakers. They're called BGP speakers. Any router that is connected in a BGP network, we refer to it as a BGP speaker. Okay. Yeah. Now let's look at BGP message types. BGP message types. So BGP supports 5 message types. Namely, we have open, we have update, notification, keep alive, and route refresh. So the type of messages that we find here will be used during BGP communication and negotiation of the link. Okay. So we have the first message, or rather the first packet type, and it's the open message. So open messages are used especially to negotiate the parameters of a link, other BGP peer parameters. Okay. So after the TCP connection is established, okay, after the TCP connection is established, open messages are sent. So the open messages are used now to exchange the BGP peer parameters. Then we have the update message. Now the update message is sent to update routing information. So whenever a BGP router discovers a new route, it will send an update message to other peer devices. Okay. Then after the BGP, so we use it especially after the relationship has been established and routes needs to be exchanged between routers. That's when we send the update message. We have another message known as notification message. So this one is used to report errors in information transfer. Okay, yeah. So it's used to send notification messages to peer routers indicating errors in communication. Then you have another type of message known as keep alive message. Keep alive messages are used to maintain peer relationships. Okay, yeah, they are used to maintain peer relationship. We call them keep alive messages. We have route refresh messages. Now, a route refresh message is used to trigger a re-advertisement of routes. So it can be sent by a neighbor, a local router to a neighbor, requesting the neighbor to re-advertise its route. In other words, to share its routing information. Okay, we refer to this as this. Okay. Now we have what we call the BGP state machine. Now the state machine indicates the steps that a BGP process will do from dead state to, or rather what we're calling idle state, to the established stage. The established stage is that last stage where we have established BGP relationship and we can be able to send keep alive messages which are used to maintain the BGP communication. So follow is continue as follows. We have idle state. So the idle state is that state when two routers are preparing to exchange or to negotiate for TCP connections. So remember we say TCP, BGP uses TCP and it's TCP port number 179. So during a TCP communication, two devices have to exchange or rather have to negotiate the link first, then forward traffic later. So they negotiate the links using what we call TCP three-way handshake. So once the TCP three-way handshake is over, is when now we start now negotiating and sending the connect message. So the connect, we send the open, sorry, not connect. So during connect stage, this is where we are trying to establish TCP connection. Okay, so if authentication for your TCP connection is required, is where now we need to perform that. Okay. So authentication is completed during TCP connection setup. So if the TCP connection fails to be established, the local router enters what we call the active state. So active means that an attempt to connect was previously initiated, but it failed. Okay. Yeah. So active means the TCP connection failed to be set up, and the local end attempts to establish the TCP connection repeatedly. Then we have another state, or other stage we call open send. So open send means we have established the TCP connection. So the local end sends what we call open packets carrying parameters which are used now to negotiate the BGP peer connections or BGP communication. Then you have the open confirm. So this is a state where after the parameters and capability negotiations in the open message have been negotiated successfully, then the local router sends what we call keep alive messages and waits for the keep alive messages to be acknowledged at the end. So once keep alive messages are acknowledged and acknowledged, then we transition to the established stage. So the established stage indicates that the two routers now can negotiate and send update messages to each other. Okay. Yeah. So we are saying update messages are used whenever we are advertising routes in the BGP network. Okay. Yeah. So this is the state machine. So say it first. It starts with idle state. So idle state is where we are starting the process of TCP negotiations. Then it transition to the connect state. So connect state here, this is where we try to negotiate for TCP connections. This is where we start to connect to the TCP connection, establishing the TCP connection. If the TCP connection fails, we transition to active state. Active means that the TCP negotiations failed and we are reattempting to reconnect again. So if TCP connection is established, we transition to the open send. During open send, this is where we send open packets. Allow me to respond to some. Okay, BGP state machine. So we are looking at the connect state. We say when TCP connection fails, we go to active. We have to reattempt. So if it works, we go to open send. If it fails, we go back. We go back and reconnect again. So at open send, that's where we send the open messages. Okay. Yeah. So open messages will be now to initiate the BGP process of negotiation. And then we transition to open confirm. So here we start now sending keep alive messages. Once we acknowledge keep alive messages, now the BGP is established. So when you're checking the BGP peer relationship between two devices, use this command, display BGP peer. It will show you established or idle. Okay, so if you see idle means it is still reattempting. Okay, yeah, we establish. Then you have the BGP routing table. You can display that using the display BGP routing table command. And then you'll be able to see this routing table. It will have fields like network, next op. It will have multi-exit discriminator field. We call it multi-exit discriminator field. Some of these things we will try to see whether we can cover. If we don't manage, I will expect you to just get to understand them. Then we have the local preference field. We have the preference value field. Then we have the path and origin fields. This one will indicate the path through which these packets have been sent on the network. Okay. So this is the BGP state machine. So they will ask you to of your knowledge on this, and also your knowledge on the state machine. And that is the message types, that is open, Update messages are sent after we establish the BGP connection. So update messages carry with them routing information that needs to be advertised to the network. Okay. Notifications carry error messages. Keep alive messages are used to indicate that the relationship is established and also to maintain relationship. Okay, I hope that is clear. Now let's look at BGP route generation. How does the protocol generate routes? Okay, how does the protocol generate routes? Remember, we said BGP operates differently from ISIS and OSPF. So ISIS and OSPF, these two routing protocols they perform calculations. BGP does not perform any calculations. Okay, so IGPs calculate routing information, but BGP does not do that. So BGP, its work is to just discover routes. So it doesn't calculate routes. So BGP injects routes from an IGP routing table. Okay, it injects routes from an IGP routing table to the BGP routing table. So it injects uh, from the into the BGP routing table. Okay, yeah. So we have seen that BGP injects, it adds these routes into the routing table. So it downloads them from the IGP routing tables like OSPF, ISIS, and then adds them into the BGP routing table. So for instance, if you have OSPF here, okay, so BGP, what BGP does is that it adds these routes into its routing table. So how do we add routes the BGP routing table? There are two commands that we to be using here, or rather making reference to. One is the network command, followed by the network that you want to inject into the routing table of BGP. So this command indicates that is a new update that needs to be done on the BGP routing table. Okay. Yeah, so the network command can be used now to advertise or rather to inject routes into the BGP network. If you don't use it, then your BGP routing table will be empty. So BGP routes are usually like added. You can like add them manually. Okay. Yeah. Then the other command is the import route command. The import route command. For instance, you go to your BGP process number 200, or the BGP, we normally say BGP autonomous system number 200. Then you say import route, then you specify the protocol. So BGP can import routes like direct routes, it can import static routes, it can import OSPF routes, and it can import ISIS routes into its routing table. So if you use any of these two commands, then BGP is going to import the routes into the routing table. So similarly, BGP, similar to IGP, BGP also supports route summarization. Okay, yeah, so you can also summarize specific routes in order to reduce the routing table. Okay, yeah. So to summarize routes on BGP, we normally use a command known as aggregate command. Aggregate command. So we normally say BGP as number 200, for example, to select the BGP for as number 200. Then you use the command aggregate. Then you specify the aggregate, rather the summarized route. So you specify the network address here and the mask length. Then you say detail -suppressed. So this is the command that is used now to summarize routes on BGP. So BGP supports manual route summarization. So you can run the aggregate command in BGP to view BGP view to manually summarize BGP routes. So after BGP has learned specific routes, the device will support or rather will import the specified summarized route into its BGP. So we are saying, how does BGP learn routes? These routes are manually injected. We inject them like this using the network command, the import route command. Now let's look at BGP route advertisement rules. BGP route advertisement rules. So after BGP generates BGP routes, okay, the first rule is that only optimal and valid routes are advertised. Okay, yeah. The other thing is that the routes obtained from eBGP. What is eBGP? External BGP peers are advertised to all BGP peers. So if a router receives, let me have a topology. Let me have a topology just one moment. One moment. Let me have a topology we can make reference of. Okay, okay. We have a topology now. So when we receive eBGP, for instance, we have as 400 here, we have as 123 up here. Okay. So this router are exit points where autonomous system number 123 can connect to the external network. You can pass there or you can pass through this side of the network. Okay, yeah. So for us to connect this router, which is in AS400, with these other two routers, this is eBGP, is external BGP. Okay, so you configure eBGP between this router and this router. And we have said to advertise routes in the BGP network, we use the command network, or we use another command, import-route command. So you can have these routes injected into your BGP using those two methods, the network command and the import route command. So once these routes are discovered, have been injected on this router, which is connecting to these other sites using eBGP, we are saying that the rule is that all eBGP routes are advertised to all BGP peers. So when these routes get to the AS, once these routes get to AS 123, this router and this router are going to advertise, okay? Yeah, that route to this site. Okay, yeah. Okay, yeah. I hope that is clear. Okay, then we have what we call the IBGP split horizon. Another rule. Horizon. IBGP split horizon. Now, routes that are learned are not advertised to other IBGPs. That's what split horizon means. Okay. IBGP split horizon means that routes that have been learned from IBGP are not advertised to other IBGPs. Let me go to the topology. So we have this router here and this router are in the same autonomous system, number 123. So they form IBGP. So if this router learns about these routes that are outside here, so assuming these routes have been exchanged to this IBGP. So once they get here first, we don't need to listen to them again here. They are not advertised again. Okay. Or routes that are learned here, we don't need to advertise them to this guy because they're on the same network, the same IBGP network. I hope that is clear. Okay, yeah. So IBGP routes are not advertised to other IBGP peers. Okay, yeah. That's what we call IBGP split horizon. So the routes obtained from IBGP peers are not advertised to other IBGP peers. Number 4, when a router learns a BGP route, say for example, IBGP route from an IBGP peer, the router cannot use this route or advertise this route to its eBGP peer unless the router learns this route from an IGP. Okay, so we are saying for BGP to run successfully, BGP works together with an IGP. So anytime you're configuring BGP, for example, IBGP. So if you're working with IBGP is the BGP that is within an autonomous system. Anytime you're working with IBGP, you have to configure an IGP. A good example is ISIS or OSPF. In other words, you have to distribute the routes, the BGP routes. You have to find a protocol that is going to assist us in distributing the routes. to the routers in the IBGP network. So we have said, when we receive, or rather when a router lands an IBGP route, okay? Say for example, this router here lands about an IBGP route. From its IBGP peer, the peer is on this side, okay? The router cannot use this route or cannot advertise this route to its EBGP unless that route has been learned through an IGP. So in this situation, IBGP routes and IGP routes need to be synchronized. So route synchronization is used to prevent what we call routing black holes. And what is a routing black hole? A routing black hole occurs when traffic is attracted or rather forwarded to a network path but cannot reach its destination. So you forward you forward traffic through a certain path, but the destination is unreachable. So what happens is that packets are going to be dropped silently. Okay, so packets are dropped silently because there is no definite destination. We refer to that situation as a black hole. Okay, yeah, packets zitakuwa but you're not understanding what's happening. Call that black hole. That is a routing black hole. So when you're setting up, you need to be very careful on how you are establishing your peering and relationship. Now let's look at BGP route advertisement. So how are BGP routes advertised? We have said we have two methods of advertising routes. One of them is by using the network command, and the other one is by importing routes. So one is by using the network command to inform, or rather to inject routes into the routing table. And two, we have said is by using the import-route command. So only the optimal and valid routes of the next hop address are advertised. Okay. So to display the routing table, we use the command display BGP routing table. So the command checks and displays the BGP routing table. So a BGP routing table usually contains both optimal and valid routes with the following tags. Okay. So in case you see the asterisk, it indicates that it's a valid route. In case you see the forward brackets, then this indicates it's an optimal route. Okay. Yeah. So you need to master these two. So in case you see this sign on the routing table, say for example it's appearing here, it means that it's an optimal route. If you see the asterisk, it means it's a valid route. For instance, we have this route that is appearing here. It has the asterisk, it has the greater than kind of sign, and the I. It indicates this link, or this path, or this route is valid and optimal. Okay. Yeah. Rule number 2. We have said the routes obtained from EBGP peers are advertised to all peers. If you receive EBGP routes, All right, sorry for that. So the second rule was routes obtained from EBGP. EBGP is external, right? So when you get EBGP routes, they will be as forwarded to all peers, right? Including other BGP peers. Okay. So if routes, so the route that router 2, for example, obtains from EBGP peers. For example, you have an EBGP peer router 4, which is on AS8 300, and you have another EBGP peer, which is on AS300 on this side. The numbers should be different here, though. This one can be something else. So we're saying these routes are advertised to all EBGP and IBGP. So router 2, once it receives those EBGP, to send them to router 3, which is an IBGP peer, and it will also send to router 1, which is also an EBGP peer, and any other EBGP peer that is on the network. Okay, yeah. Rule number 3. The BGP routes obtained from an IBGP. Okay, these ones are not advertised to other IBGP peers. For instance, here we are given that assuming router 1 receives an IBGP route from router 3, yeah, so that route is not advertised anywhere else. Okay, so this one is what we call the split horizon. Okay, so it prevents loops. It's a kind of a way of preventing routing loops. So once you receive an IBGP route, we don't send it out, okay, in the same autonomous system. So this, if we are to send out the same in the same autonomous system, that will bring a routing. Okay, so a BGP route can only be transmitted to one next op in a autonomous system. So if IBGP peers establish full mesh connections, then the load of the services will increase. Okay, so when you're setting up, so full mesh means you are establishing peering between router 2 and router 1, and also router 2 and router 3. And when you get to router 3, you also establish peering with router 2 and router 1. And you get to router 1, you establish peering with router 2 and router 3. That is what we call full mesh. So full mesh means that you're going to have very complex configurations, and you're going to also have an impact, or rather the load is going to increase on your processor and memory. Water asks, why are routers being received by EBGP peers? Why are routes received by EBGP peers being advertised while routes being received by IBGP aren't? Okay, so we have seen within the same autonomous system number, we are saying when you receive an IBGP route, don't send it to anyone else here because it will result into a loop. Now, I mentioned that when you're setting up BGP, the first thing that you need, for example, IBGP, when you're setting up IBGP, the first thing that you normally do is you configure an IGP protocol like OSPF and ISIS. Okay. So when you're setting up your BGP, you first set up an IGP. Let me give you an example of what I'm trying to put across. For example, under AS123, here you can see you have 3 routers here. Okay, so for these routers to communicate, first to ensure that these routers are communicating using IGP. Okay, yeah, you first ensure the routers communicate using an IGP. Then once, assuming the IGP is OSPF, so once OSPF is working, now you configure BGP. So we want to configure IBGP between only these 2 guys. We can exclude this one. Okay, yeah. So how will these 2 routers communicate or rather exchange BGP information? So those BGP routes will be distributed by OSPF. Okay, yeah, we use OSPF, or rather we use an IGP to distribute routes that have been learned in the autonomous system. So when we say that IBGP routes are not supposed to be sent to another IBGP router, is because they are going to result into a loop. You already have a way that we can communicate. In other words, this router can see that you already have a BGP entry here. So instead of keeping redundant files or rather redundant records, which are going to trigger a loop, we are saying that the rule is that maintain IBGP routes in one area. Once they're learned, don't send, okay? Yeah, don't send them out. Those other router can still refer to them as they are in that area. It's a way of ensuring that we can have what we call dual homing. Dual homing. Dual homing. Okay, dual homing on the network. Dual homing means, assuming this is an organization network, okay? Yeah, like Airtel or Safaricom. Okay, Safaricom network is covering a large area within the country. So assuming Safaricom connects with Airtel, their network is smaller. So that means if we're going to learn routes through this path of the autonomous system, we don't need to send these routes here again, okay? Why? Because they're going to create problems. Loops is what we are trying to avoid, okay? So split horizon is one of the mechanisms that is used to ensure that loops are avoided, routing loops are avoided on the IBGP network, okay? So, and what is split horizon? Is where we prevent an IBGP router from exchanging IBGP routes with its peers, okay? Yeah. But when we get external routes, say for example, this is Airtel, and Airtel has sent a route to Safaricom over here. So this Safaricom router should distribute all these routes to all these routers that are in the path. Okay. Yeah. Hope that is clear. Now let's look at path attributes. Path attributes and route reflectors. Let's look at path attributes and route reflectors. I would like us to take a break of 10 minutes, then we continue. Let's have a break of 10 minutes, then we continue. Okay, welcome back. So we're going to look at BGP attributes. So earlier on we said BGP uses path attributes to determine the path through which packets can take to certain destination on the network. Now, attributes are going to be distributed in these categories. Two major that are well-known attributes and optional attributes. Okay, we have the well-known attributes and we have the attributes, optional and well-known attributes. So well-known attributes can be identified by all BGP routers. Okay, well-known attributes can be identified by all BGP routers. These ones can be learned by any vendor router. Okay, any vendor equipment can be able to learn about this one. Now they are categorized into two. They are what we call well-known mandatory attributes and well-known discretionary attributes. Well-known mandatory means it's a must that they have to be included in the update message. Remember, update message are BGP messages that are used to carry BGP routes to neighbors. And we have well-known discretionary, means that it may be included in some update messages and others it may not be included. So for well-known mandatory attributes, we have origin, which indicates the origin of packets or the origin of routes. And we have the AS path, which defines the path through which packets will take to certain destinations of our BGP network. Then we have next up. So these three are well-known mandatory packets. Then we have well-known discretionary. So we have said well-known discretionary are attributes which may or may not be included in a BGP update message. And there are two of them. We have the local preference and we have the atomic. We have other attributes on this side where we have the optional attributes, where we have the optional transitive and the optional non-transitive. They're going to ask you about these attributes. So the optional transitive, we have the aggregator and community attribute. Now, community attribute is used to indicate routes that belong to the same, or rather that require the same treatment on the BGP network. So we use the optional transitive attributes community to refer to attributes within the network that need to be treated similarly. Then we have the optional non-transitive. Optional non-transitive. So transitive optional means a BGP device may not identify this type of attribute, but still accepts and forwards these attributes to peers. Okay, so optional means that a BGP router may not recognize them and hence can still allow them to pass to other areas of the network. So for optional and transitive, we have the multi-exit discriminator, which is used now to indicate or to identify areas within a BGP network where traffic can enter in multiple, or rather, traffic can leave their autonomous system through multiple points. For instance, we have a topology here where is a good example of something that needs to, or rather where we need to configure something like MED, multi-exit discriminator. That is used to identify a suitable part of the autonomous system where traffic can leave the autonomous system. It can either be on this side or traffic can be allowed to move from this side. Okay, we call it the multi-exit discriminator attribute. This one is an optional non-transitive. So optional non-transitive means a BGP device may not identify this type of attribute, in which case It will ignore them without advertising it to neighbors. The optional transitive means the BGP peer or the BGP device may not identify this attribute, but it will allow it to pass. Okay, so these two may be sent to a BGP device or router. The router may not be able to identify them, and hence they will still be forwarded to other peers in the BGP network. Okay, so I would like you to just know them as this. Uh, the exam may not really ask you details at this level. We are anticipating things are not going to be that tough. Uh, but in case you need to prepare for the worst and expect the best. Okay. question mark in the routing table of BGP, that means that the route was learned using the import route command. Just know that one that way. Another attribute that's PTID, so I'm just going to give you a logic. The other one is next op. The next op attribute is a well-known mandatory attribute and is used to specify the next op address to the destination network. So hii ni rahisi kujua, right? So as BGP routes have been advertised using the update message, the next op will indicate the next op address to the destination network. Okay. Yeah. Then we have local preference. A local preference attribute is a well-known discretionary attribute. So it may or it may not be carried. So this one is used to inform routers of the preferred path as they leave the autonomous system. So this one appears, this one is used on an IBGP. Okay, yeah. So for example, if routes are leaving this router here towards the outside of the autonomous system. So we have two exit points. We have router 1 and router 3. So the local preference is used now to determine which path, or rather which side of the autonomous system is suitable for leaving the autonomous system. Okay, yeah, that one is easy. So I'm just going to not well in how they work literally. Then now the community attribute, I say this one is used especially when you want to identify routes that have the same network behavior characteristics. Then we have similar characteristics, then we can identify these using the community. So community attributes as an optional transitive attribute. So when a router receives an update message that has the community attribute, it indicates that these are it refers now to routes that need to be treated with the same kind of behavior. All right. Yeah. So it's optional transitive, meaning if a router does not identify the community attribute, it will still forwards it to the peers. So we have several, these ones you can be asked. For the community attribute, then ask questions relating to this, in that we have these 4 community attributes. So if the community attributes indicate internet, that means a BGP device can advertise the received route with the internet attributes to all its peers. So by default, all routers belong to the all routes belong to the internet community and they advertise to peers. So if it is indicating no advertise, means once a BGP device receives the no advertise attribute, it does not advertise these attributes to peers. Okay. Then we have no export. No export means that once a BGP device receives the update message with no export, that we should not send this, or rather, we should not advertise this out to neighbors. Okay. Then we have no export subconfederation. Okay. Now, subconfederation is a technique. Currently, I think we are trying to move away from it. It's a technique where you can have clustered BGP, a clustered BGP network, where you have an IBGP. In an IBGP, you can have other small BGP networks within it. Okay, so let me try to put this one to you. Is where, assuming we have this IBGP network up here, 123. So confederations means inside this BGP, you can still have other small networks with routers. Okay, we call them sub-confederations. Okay, within a large BGP network, you can have small ones. You could have other routers that are also connected in that manner. Okay. Yeah. So subconfiguration means that you have a clustered kind of IBGP network. So in this case, if you see the no export subconfiguration means once a BGP router receives the no configuration, it means that we should not send, or rather we should not export to the subconfederation network. Okay. Yeah. Okay. Yeah. So those are then we have MED. MED stands for multi-exit discriminator. It's an optional non-transitive attribute. It helps in determining the optimal route when traffic enters an autonomous system. So this one is used during entry, and then ingine ilikuwa inaitwa local pref. Natumia, sorry, where is local pref? Natumia hii local preference when traffic is leaving. So local preference is for traffic leaving. MED is for traffic coming into the autonomous system where we have multiple entry points. In other words, where we have dual armed entry points. Okay. Okay. Yeah. So this one determines which part of the autonomous system is suitable for incoming traffic, right? Yeah. You'll read, they will not ask you so much details of how that. So we have the atomic aggregator. These ones are well-known discretionary attributes. Okay. They're used when summarizing routes. Remember we said the aggregator command is used to summarize BGP routes. So the atomic aggregator and the aggregate and aggregator are used especially when you are exchanging summarized routes to other peers. Then you have preferred value. Preferred value is usually a Huawei specific attribute. This one is not found on Cisco or any other vendor. This one is for Huawei. Okay. So this one is valid only on the local device. This one is not sent out to other areas or other outside an equipment. Okay. Yeah. So it's not only used within the local device to determine exit points or rather on that particular device. So those are the BGP attributes. We have another concept we call route reflectors. Now, what are route reflectors? Now, to prevent the full mesh, what is full mesh? We said full mesh is where you configure BGP peering between all the routers. So you set up a peering between this router and this router, peering with this router and this router, okay? And peering from this router to this guy, and also peering back to this guy, okay? Yeah. So this is what we call a full mesh. But now, full mesh configurations have issues in that they put a lot of load on the processors and memory of the devices. So to avoid this kind of mess, we configure what we call a route reflector. A route reflector acts like a pivot point within that network. So the route reflector is what is used now to distribute routes that have been learned in different parts of the IBGP. Okay, yeah. So when configuring an route reflector in an IBGP, we configure the one router as you can have multiple of them, not that. You can have one router or you can have multiple routers which are working as a cluster as route reflectors. and the other routers that are not route reflectors become clients. So what our app does is that it reflects LAN routes so that IBGP routes are advertised within an autonomous system. Okay, yeah. Give me a minute. Okay, so route reflectors are used to reflect routes within an autonomous system. Okay, yeah. So instead of having the full mesh configuring so difficult configurations in the IBGP, you only pair this router with this router and you pair this guy with this guy. Okay, yeah. It becomes very simple to manage and also to reflect routes within the autonomous system. So those are route reflectors. They will ask you about that. So route reflectors also help in loop prevention. This is that technique that we have seen, which is used to prevent loops. Okay, yeah, we use route reflectors to prevent loops on a given network. Okay, yeah. So say between neighbors and interface. Okay, so this is another way of preventing loops using route reflectors. I hope this is making enough sense. Okay, yeah. I want to believe this part will not be that tough. Okay, let's answer these three questions that we have here. So one, we are told is a simple question. Or a single answer question. Okay. So I thought which is the type of airspace attribute? Sorry, what is the type of airspace attribute? It's a well-known mandatory C. Okay. Okay. Yeah. Number two, we are told what is the function of MED? MED. They say it's used to the entry point of packets in the autonomous system. Okay. Yeah. Attributes that are used by route reflectors to prevent loops are these two. Let me show you. You have what you call the originator ID and the cluster list. They're the ones that are used to prevent loops. Okay. Yeah. Okay. Yeah. So that is BGP. Okay. Yeah. Now, since like time is not enough for us, I'll try to see whether I can share most of the notes for you. Um, from segment routing. Segment routing, well, they may test or they may not test. Last year, the exam was a little bit tough. This year, it's not tough, right? Yeah, it was something that was manageable. Okay. So here, we're going to see things like that is the areas that I want you to look at. I'll share this document, though this one is not for this year. It will be like a reference point for enabling you to know which areas to order to look at in your preparations for the exam. Someone is asking, seems like, let me check. Okay. So networking, whether you know how to, you can be able, there's no practicals here. It will be basically theory. I'll share the notes for this, assessed notes. Okay. Yeah. So today, beginning of today, I'll share all these notes, describe what exactly the processes are talking about. Okay. Yeah. Any questions? Then this datacom, I see datacom is so wide. We also have BCN. BCN, they will not test so much. It will be very easy questions that you can manage. So they will test you on things like supercomputing aspects, cloud integration and containerization, and a little of DCN security solutions. I'll share all these more short notes that are pre-processed so that they can help you learn faster. Now for security, I'll share also notes, very brief notes that you can look at. Let's not sleep. Let's try our best to be the best in these national finals. I will also share notes on WLAN roaming, planning questions, actually popular WLAN planning basics. I will share notes, processed notes. Okay, yeah, I will share them beginning of night, and I will hope that you will try to prepare. Okay, yeah, please don't sleep. There's one student who was giving me a testimony that amekuwa akilala saa 9 asubuhi. Yeah. Someone is asking, is the certification points applicable at this stage? There's another question. How can one ask the multiple question sections? Do you know the number of answers they want? No. The multiple choice questions may not really, you may not be really know exactly. They don't so many answers are correct. Sometimes don't go there with the mentality that some of the answers are wrong. Okay. Yeah, don't use that mentality there. All the answers could be right. Yeah, or one could be right and majority wrong. Okay, try to reason out. And the beauty about this exam is open book, so you can still try your own ways of getting there. Okay. Any other question? Can they put a single answer question in multiple answer questions? Yeah, it's possible. That's why I'll say don't go there with the mentality that you have a wrong answer, you have a right answer and stuff. So just read the question, try to understand it. Okay. Thanks for simplifying. We have so much to go through. Yes, we have so much to go through. Yeah, thank you. Tibet says, if a box, then it's multiple. Yeah, okay, okay. But they're usually indicated sometimes it's a multiple. So you'll check index up there. There's something you weren't clear. The certification points you have said apply or do not apply. This is a question that this time is a little bit big for us. Ask it in the group. We have the representative from Huawei, Michael Kamau, will answer. Okay. Yeah, kindly answer that. Ask that question. Ask that question. Uh, Junior, do you have a certification currently? Now, Gregory Nasole is asking, is there a certificate for participation at national stage? What we'll do at national is that for those who will qualify, we presented with certificates and presents. Okay. Yeah. At this stage, we do not have a certificate, but those who will qualify for regional finals, you will get a certificate. And also, as you qualify for regional finals, this is not the end. Okay. Yeah. Give it your best. Please try to give it your best. I know there are not many because of the recent strikes. So it's a time that you can really prepare well. Wasilale, I was saying there's a student who was telling me, Mekwakilala to ticket to China and to South Africa. Okay. I had a student who was in first year, first semester, and he got to China ticket. And it comes also with some. So last year, students got laptops which are very expensive. I don't know whether you have ever seen a Huawei laptop. It's damn expensive. Some are like 450K. Okay, and they are good. So Huawei laptops are usually like very expensive and good. So students got laptops, others got tablets, mobile phones, very nice mobile phones, and smartwatches. Okay, yeah. I will encourage the ladies. The ladies kindly try your best because we also have another recognition known as women in tech. Okay, so the women in the group kind of come up, right? Yeah, do they give those who qualify for it? Yes, yes, yes. You'll get some very nice gifts, and you also have cash prizes. Okay, yeah, cash. Besides those laptops, you also get some cash. Like there's a year we were getting, each student was getting like 70K deposited plus those laptops and blah blah blah. Yeah. So try your best, be the best of the best. Get 900. Okay. I want us to be talking of. I was tying with another student. What are we going to do? Okay. Yeah. Someone's asking. Ninga is asking. Certificate of participation awarded. Yeah, certificate of participation. The Huawei competition is a known activity. Actually, Huawei absorbing new employees. So if you have that kind of certificate, that shows that you've gone through that training, gone through that rigorous testing and stuff. So know that you're someone who can deploy solutions. So I would like you to read, add, and prepare on these areas. Okay. Yeah. During the exam, just compose yourself. Make sure you win. So this is an exam that you will be expected to almost get 100 or rather 1,000 points. What is the qualification for regional? Be the best. Everyone is a winner. As you're going to realize later, those are going to qualify for the competition. You're going to realize as you get to China, all participants are winners. Everyone is a winner. Okay. Yeah. So everyone is a winner even up to this stage, but we want the best. Who is number one to number? Okay. Yeah. Who is going to be number one to number 6? We get you can loop on 19. This one is for Machakos. We are mixed. Group or 19. Yes, yes, I will be around. Have you ever gone to regional, sir, as a student? No, I've been a trainer since 2018, training. And since 2021, uh, we have been taking students to global finals. So, ukipita nationals, just jua wewe utafika time. Sir, my network card, is this the last class? Yes, it's the last class. Will the certification points count? Kindly clarify. Kindly ask this question on the WhatsApp group. Someone will respond. Kindly ask that question. We have someone from Huawei Technology will be able to answer that for us. But if you have a voucher that is there, just do the exam, okay? To be safe, you can do the exam tomorrow before the competition. Okay, if no more questions, then now let's take all questions to the WhatsApp group. We'll be able to respond to them there. Have a nice evening.